All right, this problem involves two ships sailing with a 110-degree angle between them. One of them is traveling 25 miles an hour, the other is traveling 22 miles an hour, and they asked how far apart are they after 2.1 hours. So the distance traveled by the first one is 52.5, and the distance traveled by the second one is 46.2. So those are those numbers. And the question is, how far are they apart? So what's that diagonal distance? Now, before we know the law of sines or cosines in this case, there is still a way to do that, in that if we extend this side out here and drop a perpendicular, because all we have now are right triangles to work with, what I can do is I can find this length and I can find that length and then use Pythagoras to get the hypotenuse. So if that's a 110-degree angle, then this is the supplementary angle being, they got up to 180, so that must be 70 degrees. So now I can use a right triangle trig here with a hypotenuse of 46.2 to get these two lengths. Let's call them x and y, where x is the adjacent side. So the cosine of 70 degrees is x over 46.2, which multiplied by 46.2, x is 46.2 times the cosine of 70 degrees. And then using the opposite side here, y, and y over 46.2, that would be the sine of 70 degrees is y over 46.2. The unknown side and the known side, the opposite and the hypotenuse, that's sine, right? For this first one, the unknown side was x, the known side was the hypotenuse, so that's cosine. Anyway, that leads me to y equals 46.2 times the sine of 70 degrees. Once I have those two numbers, then what I'm going to do is I'm going to take whatever I got for y, square it, take whatever I got for x, add it to the 52.5 to get that whole side, square that, and this should equal the square of the answer that I want. So my question mark squared, so I would then take the square root of that, the square root of that, to get that diagonal. Okay, so this is possible to do without the law of sines or cosines. Drop a perpendicular, get something to work that way. Yeah, I'm trying to think. I was thinking if there's another way, if I drop perpendicular this way, but this is the angle that I know from that one, so this is probably the best perpendicular to drop there. Anyway, one other way possible is you could have extended it out this way and dropped this perpendicular, in which case this would have been 70 degrees, and you would have found this length and that length. Anyway, it's equivalent to what we did. But anyway, there we go.